Excuse me, anyone here? Anyone hear me? Hello?
Yes, you are audible.
Ma'am, this is revision session for week 5 and 6.
Yes, hello.
Yes.
Yes, this is revision session for week 5 and 6.
But today's I am saw the calendar, no, my calendar in the morning. It is showing the TA session today.
Your calendar was not updated that time, but on Saturday itself we sent a mail regarding that. It was postponed. Okay. Did you check your mail?
Yeah, I got in mail, but I am checking it in the morning for revision session, but it can't show in my calendar. So I think this is a TA session, but this is revision session. Okay, I can check it.
Okay. Yeah, okay. So now we can start with the session. Okay.
Ma'am, can you go the week 5 and 6 for in a basic?
Yes, we will revise the concepts and then we will
Yeah,
solve
yeah,
the
yeah,
problem.
ma'am. Ma'am, can you revise the and any every concept in a basic to
Yes,
advanced
yes.
type?
Yes, yes. We will revise the concepts. Okay, is my screen visible?
Yes, ma'am.
Okay, just a minute. We'll start. So basically,
Ma'am, your voice is breaking, ma'am. Ma'am, your voice is not coming.
It's buffering, ma'am.
No, ma'am.
Ma'am, voice is coming. Voice is buffering, ma'am. Your voice is buffering.
Okay.
Hello. Hello.
Ma'am, your voice is not coming, ma'am.
Bro,
अरे भाई
wait.
वॉइस
Hello.
बोला नहीं, वॉइस बोला ही नहीं ना।
Hello.
Yeah, ma'am.
आपसे ही आ रहा है।
Hello.
Ma'am, no, it's coming.
Yeah.
It's
Now
coming now.
it's fine.
No, ma'am. This is buffering.
No, again buffering.
Is it adjustable? Hello.
Yeah, ma'am.
Yes, ma'am, you are audible.
Okay. Is it adjustable or it's too bad?
No, ma'am. This is buffering again. ma'am.
No, again,
Ma'am,
stuck.
still.
Voice is getting stuck.
Okay. Okay, just give me a minute. Maybe there is an issue with my earphone. Is it fine?
Now it's fine for now.
Now it's yeah.
Okay. Okay, now I hope that you all have seen the lectures and the previous sessions recordings for week 5 and 6. Is it?
No, ma'am. I am missed some lectures. Can you go in a basic?
My voice is fine now?
No,
And
ma'am. Your
again
voice is
buffering.
not fine. Again buffering, ma'am.
Okay, now I can't do anything else. I have changed my earphone. So if it is adjustable, then please back till.
No, ma'am. This is not adjustable, ma'am. Because no, your voice is totally breaking, ma'am.
Is it for everyone?
Yeah, ma'am. Small, okay. When lengthy sentence you say
Yes,
fully
ma'am.
buffering.
Okay, I'll rejoin the meet.
हेलो
Hello. Hello.
भाई
Ma'am,
Hello.
ma'am.
She told she will rejoin.
Currently, ma'am is not here.
No, now here.
Hello.
Yeah, ma'am.
Time better or same?
No, this time is better.
Good evening, ma'am.
Yeah.
No, ma'am, this is
Good
again
evening,
buffering,
everyone.
ma'am. Your voice is again buffering, ma'am.
Ma'am, if it is not fixable, can you reschedule the meeting?
It is already rescheduled, so
Ma'am, please don't reschedule because quiz 2 is on head, ma'am. 3 or 4 days ago, the quiz will be appear.
yes, we understand that.
Maybe like tomorrow morning, if it's possible.
Okay, so the voice is like it's not adjustable at all, huh?
No, ma'am,
No,
this
it's
time is okay.
okay.
This time is
Now,
okay, ma'am.
now, ma'am,
But
okay.
when continuous sentence
Sometimes
it
your voice
starts
is
doing.
breaking. When you speaking continuously, ma'am, then voice is breaking.
Okay, so okay, I'll start with the session, and if it is being too much problem, then you can just tell me, okay? But try to
Now this is fine,
understand.
ma'am. Fine. Can you
Yeah,
start
it
the
will be
session?
fine in some time. Yeah.
Yes, ma'am.
Okay, let's not waste the time. Okay. Okay, yeah. So the topics in week 5 is mostly it is based on the function of continuous random variable. Okay, so in week 4 you have seen what is a continuous variable and what is PDF and all about a continuous random variable. Okay, so from week 5 we will start for the function of continuous random variable. Okay, so the first topic is function of continuous random variable. Okay, so these things we will study, and then for a function of random variable you will find PDF and CDF. These things you have to study in week 5. Okay, and then you have to find the expected value and the variance for the function of random variable. Okay, expectation and variance. Okay, of a function of continuous random variable. Okay, so yeah, these things, and the next we have discrete continuous joint distribution. Okay, where one random variable will be discrete and the other random variable will be continuous, and we will study about their joint distribution. Okay, so these are the major topics for week 5. Okay, these are the topics for week 5, and then in week 6 we have, okay, so in week 6 we have to study the joint continuous random variable. Okay, we have to see
Excuse me,
jointly.
ma'am.
Yes.
Can you not cover a marginal distribution and conditional distribution in a week 5?
Yes, we will see the questions. I'm just writing the name of the topics now. Okay. And then we will discuss the topics as well. Okay. So then we have jointly continuous random variable in week 6. And we have 2D uniform distributions. And then we have to study about their independence. Okay. Also, we have okay.
Ma'am, your voice again breaking, ma'am. I feel.
No, this time it's okay, ma'am.
Okay, okay.
No voice for me.
Okay, for a continuous random variable. Okay, so these are the major topics for week 5 and 6. Okay, so the very first thing is
Excuse me, ma'am.
for week 5. Yes.
Ma'am, I think in a week 5 the marginal topic will be here, but you can mention in a week 6 the marginal and the conditional.
Okay, don't worry. The week doesn't matter. You should understand the topic. Okay. In week 6 also there is in 2D distributions you have to find the marginal and conditional densities. Okay, week 6. In week 6 it is also there. Okay.
Ma'am, can you go the topic wise in a week, because I am making a notes and revise for background. Then I attempt a question for.
Yes, I am discussing the topics. Okay.
Okay.
Okay, so first of all, you should know how to find the CDF of the function of continuous random variable. Okay, so suppose you have a random variable x. Okay, so let x be a continuous random variable. Okay, with CDF fx. Okay, so first of all, you have a random variable x, which is a continuous random variable, and have CDF fx. Okay, so this is the notation for CDF. Okay, and it has PDF fx. Okay, I hope the difference between PDF and CDF is clear to everyone. Okay, so this is the CDF for x, and this is PDF of x.
Ma'am,
Okay?
excuse me, ma'am.
Now,
Ma'am.
yes.
Excuse me. Can you tell me the PDF is a probability of a function and CDF is a, what is the CDF?
CDF is the cumulative distribution function. Okay, so it accumulates the probability up to a certain point. Okay, you have to add the probabilities up to that point.
I am asking. I know the in full form, but what is CDF find like? It is the found the area type of thing.
Okay, see, CDF is probability x is less than or equal to at that point. Okay, so this is some point x. Okay, so you have to add all the probability up to that point. Okay, okay, so this is a random variable x. You are given CDF and PDF. Now we are defining a function of random variable x. Okay, suppose it is y. Okay, so y is some function of x. So we are defining it as gx. What is gx? So gx is some function which is defined like from real to real line. Okay, so it is some function. Okay, so y equals to gx is also a random variable. Okay, it is also a random variable. Suppose with CDF fy. Okay, now how will you find the value of fy is? Okay, so this is CDF of y. How will you find the CDF of y? What is the general formula for finding out the CDF? What should I write here first?
P of y less than or equal to small y.
Yes, ma'am.
Yeah, so capital Y is less than or equal to some value small y. Okay, now we are given that this y is equal to gx. Okay, gx is some function of x. Function, maybe it might be x plus 5 or 2x plus 3 or x2, something like that. So these are the function x. Okay, so y is something like this.
Can you repeat, because your voice is breaking was this time?
Y is some function of x. Okay, just you tell me what is the function of, what do you understand by function of x? If you have a random variable x, then what do you understand by a function of x? Do you have any idea about it?
Ma'am, your voice is currently not coming, ma'am.
Hello?
You're audible, ma'am.
Ma'am, you are audible.
Ma'am, yes.
Okay. Okay, if I am audible, then please don't make such things that I am not audible and all, okay? Okay, so y is equals to gx. Okay, so we can put the value of y here. Okay, so this gx is less than or equal to small y. Okay, so what we have to do, at the place of y, you have to put the value of the function. Suppose for an instance, suppose it is 2x plus 5. Okay, so what you have to do, you have to put 2x plus 5 is less than or equal to small y. Okay, and from here you will find the value of x. Okay, you have to, like, at left hand side, you have to put x only. Okay, and whatever
Ma'am, in this
the
case, what
other
is the
part is
represent small y, ma'am?
small y is some value of capital Y. Okay, small y is value of capital Y.
But ma'am, you are putting the value of a capital Y gx. So what at this time capital Y is represent, ma'am?
Capital Y is function of small function of x. Okay, y is function of x. Function of x, how would if so they both are equal to each other. Okay,
Ma'am, I know the function of x, but you can put a value of y, like y is less than equal to small y. You can put the function value g of x is less than equal to y. So what is the represent of y, small y, ma'am? Not a g of x, ma'am. What is the represent of minus small y, ma'am?
okay, you have some random variable y. Okay, you understand what is a random variable?
Yes, ma'am.
Okay, so it will be defined, suppose it is a continuous random variable. Suppose it is defined the interval 0 to 1. Okay, so 0 to 1 is the range or support of x. Okay, so this y is some value in this range. Okay, suppose it is 1 by 2. Okay, so here we are asking that y probability that y is less than or equal to 1 by 2. Okay, so here small is like
Ma'am,
in
excuse me,
general
ma'am.
representing it as small.
Ma'am, can you tell me ki, when I am putting the value in a function, then it gives a support like minus small y. Am I right?
Sorry, what?
When I am putting the value in the function like g of x, then it is give a small y, have random support value.
See, it is not support. I am just saying, just try to understand. Okay, your basics are not clear. Okay, so we are saying that these are two values. Okay, some values in which y is defined. Okay, so we are just saying that this y is less than or equal to some particular value small y. So this is small y can be any value. Suppose it is 1 by 2 or 1 by 4 or any
given in a
value.
question. It is a given in a question, huh?
Yes, it will be given in the question.
Okay,
Or
I understand.
okay, so CDF up to that certain point, you have to calculate the probability. You have to add that. Okay, so in general, we are writing it as small y. Okay. Okay, just answer me one thing. If you have to represent a random variable, so you will use a capital letter or a small letter, capital X or small x. And if you have to represent the value of a random variable, then will you use capital letter or a small letter?
Small letter.
Small letter for what?
To represent the random value.
Okay. Why are you asking this thing? If you know. So capital small y is some value of the random variable, capital Y. That's it. Okay. So that will be given in the question, or the question, like from the question you have to decide. Okay. Maybe it is given in general.
You can
y.
put in this as general formula type of thing.
Yeah, obviously whenever you study something, you study it generally, not for a particular value, right? And then you can apply the formula to the different values. Okay, I hope it's clear to you now.
Yes, ma'am. Yes, ma'am.
Okay, so this is how you can find the CDF of a function of random variable y. Okay, so let's suppose, just take an example. Suppose x is a random variable which is following uniform distribution in the range -1 to 2. Okay, Now we are defining a function of x, which is represented as y, okay, which we write as gx, that is equals to 2x. Is this thing clear to everyone? What is y, what is gx, and what is 2x? Okay.
Yes, ma'am.
So 2x is the function of x. Okay. So that we, like, for notation, we are using it as gx. Okay, and that we also write as y. Okay, they both are same. Okay, so now we have to find the CDF of y. Okay, find the CDF of y. Okay, this is your question. Okay, now tell me, how will you solve this question? So first of all, it is asked that we have to find the CDF of y. So it is not written that you have to find the CDF of y at a particular value. Okay, so in general, you will write small y. Okay, if it is given that you have to find the value of CDF of y at some point, suppose 2, then you have to put fy2. But if it is not given, you have to find it in general. Okay, so you will put small y. That is the meaning of small y here. Okay, so now according to the formula, we can write that it is y less than or equal to small y. Okay, this is according to the formula. Okay, and this we can write that it is 2x less than or equal to small y. That we can write that it is capital X less than or equal to y by 2. Is this clear up to this point?
Yes, ma'am. Yes, ma'am.
So
Yes,
now,
ma'am. Yes, ma'am.
okay, now what is this thing? This is what? This is CDF of x at point y by 2.
Y by 2.
Yes. So what we have to find now? We have to find the CDF of x. Okay, we have to find the CDF of x at point y by 2. Okay, so we will find the CDF of x here. Okay, now since x is following a uniform distribution. Okay, so uniform is it's a standard distribution. So we know that CDF of uniform distribution. Or if in
Hello,
case
ma'am.
you don't remember the formula, you can calculate it. Yes.
Yes, ma'am. Here range of x is between 0 to y by 2, no?
Sorry.
P of x is less than equal to y by 2, then its range belong to 0 to y by 2. Yeah, फिर I think. मैम रेंज x का रेंज कहाँ से कहाँ तक होगा मैम? यहाँ पे x is.
You tell. Okay, the distribution of x is given. Now you tell what will be the range of x.
Yes, ma'am.
What values x can take.
Yes, ma'am.
Yeah, tell me the range of x. What values x can take here?
0 to y by 2.
Why 0 to y by 2?
Because मैम x पॉजिटिव वैल्यू लेगा ना मैम CDF में.
No, I am asking what are the values taken by x. What is the range of x?
-2 to 4.
It's given -1 to 2.
Yes,
Okay, this is the distribution.
-1
If
to
you
2.
guys, yeah, you should at least know what is the PDF, what is the range of a random variable. Okay, if you don't understand the basic things, then you will find difficulty in understanding these things. Okay, so try to understand the basic thing first. Okay, so here x can take values from -1 to 2. Okay, the distribution is already given in the question. Okay. Okay, so now we have to find the CDF of x. Okay, so CDF of uniform distribution, do you know? Do you remember? So if x is following, if x follows uniform distribution with parameter a comma b, okay, then what is the CDF of x?
1 by b minus a.
Yeah, so first of all, what is the PDF first? So PDF, we all know that PDF is 1 upon b minus a. Okay.
A.
Okay, this is a PDF. Okay, now if you have to find the CDF. Okay, so CDF will be So if x is less than a, then it is 0. Yes. And if x is greater than b, then what will be the value of CDF of x?
1. X minus a.
1. Okay. Okay. If it is between a to b,
X minus
then it
A.
is
X minus
x
A
minus a of
divided
1.
by B minus
Will be minus a.
Okay. And if you don't remember these formulas, then you have to go with the method and you have to integrate it. Okay. And you can find the PDF, CDF. Okay. If you don't remember it. If you remember it, it will save your time in the exam. Okay. Now let's go back to the question. So according to the question, x is following a uniform -1 to 2. Okay. So you can see that here. What will be the value of fx? Small fx, PDF of x? It will be 1/2 minus -1. Yes or no?
Yes, ma'am. 1/3.
Okay. Okay, so it will be 1/3. Okay, x is lying between -1 to 2. Okay, so this is the PDF of x in the given question. Okay, now just put the value. So find the CDF of x here. Okay, so if x is following uniform -1, 2, then the CDF will be 0 when x is less than -1. When x is greater than 2, okay, greater than or equal to 2, it will be 1. Okay, and when it is between, sorry, +2. Okay, then it will be x +1/3. Is that correct?
Yes, ma'am.
Okay, so this is the CDF of x. Now we have to find, okay, we were calculating the CDF of y, which we calculated as, which is equal to CDF of x at point y/2. So CDF of x at point y/2. Okay, so here we have to put y/2. Right? So when you put y/2, it will be y/2 + 1 divided by 3. Okay. And what will be the range of y here?
-2 to
-1
4.
to 2.
-2 to 4, because y is 2 times of x, right?
Yeah,
Here
yeah,
you
-2
multiply
to
it
4.
here also. Okay, so it will be -2 to 4. Okay, so y is lying between -2 to 4. This will be the CDF of y. Okay, just solve it. So it will be y + 2 divided by 6. Okay, is that fine to everyone? Okay,
Yes,
now
ma'am.
just
Yes.
look at this form carefully. Okay, this is CDF. So this we can also write as y minus -2 divided by 4 minus -2. Is that correct? Yes, no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So here you can observe that what is the distribution of y?
Uniform.
Uniform.
Yeah, again. Okay, so again you can see that if you match with the CDF of uniform distribution, okay, you can say that y is also following uniform distribution. And what will be the parameters?
-2 and 4.
-2 to 4. Okay. And there is one more thing, that if you differentiate the CDF, then what will you get? Anyone?
PDF.
PDF.
PDF. Okay.
PDF,
So if you
ma'am.
differentiate, yeah. So if you differentiate, okay, the CDF of y, okay, so that will give you PDF of y. Okay. So here in the question you can see the CDF of y is y + 2 divided by 6. So if you differentiate, what will you get?
1/3.
It will be 1/6. If you differentiate this function, what will you get?
1/6. 1/6.
1/6. Okay.
1/6.
So this will be 1/6. Okay. Now if you write PDF of y by using this, that we already know that it is a uniform distribution with parameters 4 and -2. Okay, both are same. Okay, so this is verified now. Okay, so if you have CDF, if you differentiate the CDF, you will get PDF. Okay, now next is monotonic differentiable function theorem. Okay, so if you have monotonic differentiable function, so suppose, okay, suppose x is a continuous random variable, okay, with PDF fx. Okay, so let gx, okay, so this is some monotonic function and in the range of x. So what is this? X will belong in the support of x. Okay, with derivative g dash x. So g dash x is the derivative of gx. Okay, so we can write it as d by dx of gx. Okay, so then we can write the PDF of y equals to gx. Okay, so that is defined as, okay, so again what we have a random variable x. Okay, x is a continuous random variable, and we have a function of x. Okay, so here the function is monotonic differentiable function. Okay, so monotonic function, which means either it will be increasing or it will be decreasing. Okay, so you have to find the PDF of y. So there is a formula for it. What is the formula? You have to take the derivative of this function. Okay, first of all, you will be given some function gx. Okay, you have to take the derivative of this function gx. Okay, that we notate as g dash x. Okay, now at the place of x, you have to fill the value of x in terms of y. Okay, so for the notation, we write it as g inverse y. Okay, we'll solve a question, then it will be clear to you. Okay, so we have to take the mod of it, and then you have to put the value of PDF of x. Okay, and you have to put the value of x there. Sorry, value of x in terms of y. Okay, so this is the formula. Now let's see how to use it in a question.
Ma'am,
Yes.
ma'am, why do we need to take a mod in the denominator?
Because we have to always take a positive value. If you see the Jacobian thing, we take mod. Okay, so this function is actually that Jacobian, but that concept is not here.
Ma'am, what basically the Jacobian is? Or kind of we are taking a reasonable function?
Okay, let's solve a problem, then it will be clear. Okay, see, if you have fx, okay, which is defined as 3x square, and it is in the range 0 to 1. Okay. And now we are defining a function gx, okay, or y, which is defined as suppose x square. Okay, now let's see how to put the values in the formula. Okay, so what we have to take? We have to take the derivative of the function. Okay, so if you take g dash x, so what will be the value of g dash x if gx is x square?
2x.
You have to
2x.
you have to take, it will be 2x. It will be 2x. Okay, now from here you have to find the value of x in terms of y. So simply it will be x is equals to root y. Is that clear? Is it fine?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so now we have to put, so we wrote that g inverse y. Okay, what is this? We have written that gx is equals to y. If I transfer this to the right hand side, x will be equal to g inverse of y. Is it fine?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, okay, so now at the place of this x, okay, here I am putting g inverse y. Okay, and here we will put the value of x, so 2, and the x is equals to root y. Okay, so this is 2 under root y. Okay, so now we have got this value. Okay, and if the this value is negative, then we have to take positive, because we know that the PDF is always greater than or equal to 0. Yes, PDF value can never be negative. Okay, so we have to take the mod of it. Okay, so here it is already positive, so we don't need to worry about that. Okay, the next thing is we have to find this part, fx g inverse y. Okay, so fx is equals to 3x square. Okay, again at the place of x I will put g inverse y. Okay, and then here at the place of x I will put the value of x. So this is root y whole square, so ultimately it will be 3y. Okay, now we will put both the values in the main formula. Okay, this formula. So according to it, what will be the PDF of y? So it is 1 upon this value. Okay, so 1 upon 2 root y into this one. Okay, so this value is 3y. Okay, so ultimately it will be 3 upon 2 root y. Okay, is that fine for everyone?
Yes, ma'am.
Yes, ma'am.
And this formula is only valid for monotonic increasing function, right? Increasing or decreasing function, right?
Yes, it is for monotonic function. Yeah. Okay, so you don't need to mug up the formula, just understand what we are doing. Okay, so we will be given a function of x in the question. Okay, as you can see here, we are given the function as x square. Okay, so this is x square is equal to gx. Okay, then what we have to do? We have to take the derivative of it. Okay, we have taken the derivative of the function. Okay, we have taken the derivative of x square, which is 2x, and then we have to put the value of x.
So the value in form of y.
Yeah, value of x in terms of y. Okay, the function will be given to you. From there, you have to find the value of x in terms of y that you have to put here. Okay, and the next is this is what? This is the PDF of x. PDF of x in terms of y. Okay, so you just have to find the value of PDF, which will be already given in the question. You just have to put the value of x in terms of y. Okay, so these two things you have to do. Okay, now is that clear to everyone? What we are doing here actually?
Ma'am, can you tell me what things are given in the question? Like PDF value and function
question,
value and
yes.
function value and PDF value.
Yes, yes. So PDF of x is given and the function is defined. So these two things will be given to you. Okay.
Okay. The first we can derivate of x. Then we can convert x in the form of y.
Yes. Okay, and then you have to put the PDF of x in terms of y.
Okay, okay.
Okay, so PDF of x will be given to you, and the function will also be given to you. Okay, is that clear to everyone now? So in this way, you can do this thing for any of the function. Okay, next we have expectation. Okay, so if you have x, okay, which is a continuous random variable. Okay, x is a continuous random variable. Okay, with PDF fx. Okay, this is some PDF of x. Then how do you calculate the expectation of x? Expectation of x is what? Integration of x into fx. Okay, and what will be the range of this integration limits?
Minus infinity to infinity.
Yeah, so in general, we can write minus infinity to infinity. And in the question, the distribution of x will be given to you. Okay, so you can take the support of x here. Okay.
Ma'am, in the question, the range will be given.
In the question, yeah, the distribution of x will be given.
Okay, okay.
Okay, so now this is for the variable x itself. Okay, now if you have gx, okay, which is some function of x. Okay, gx is a function of x, and you have to find the expectation of gx. You have to find expectation of gx. Then how will you find it?
Integration the same way the function into the PDF.
Yeah, correct. Okay, so we have to take this function into PDF. Okay, and the range of x, support of x. Okay, in general, we write it as minus infinity to plus infinity.
So, ma'am, function into PDF is the.
Yeah, this is the function, and this is the PDF of x. Okay.
First, we can derivate, integrate, then find the value of expected value.
Yes, we have to multiply these two things, and then we have to integrate them together. Okay, that will give you the value of expectation of function. Okay. Okay, let's assume that the function is, if just for an instance I'm taking, suppose the function is x cube. Okay, so what you have to find? You have to find expectation of x cube. Okay, so what you have to put? You have to put x cube. Okay, this is the function, and then you have to put the value of PDF of x dx, and here in the limits you have to take the support of x. Okay, this is the formula. Okay, we'll see the questions later in the session only.
Can you scroll down, ma'am? Can you scroll down, ma'am? Yeah, yeah.
Ma'am, support is where we get positive value, right?
Support is where the variable is defined. Okay, the values taken by the random variable.
There's no meaning of positive or negative.
It can be negative, it can be positive, both. Okay, in that question itself, in the uniform question, you saw that x was taking values from -1 to 2. Okay, so the random variable can take positive value also, negative values also. Okay, and this is the support of x.
Okay, ma'am. Thank you.
Okay, so next we have a discrete continuous joint distribution.
Ma'am, variance.
Yeah, variance also you can find in this way. So what is the variance? So variance of x, okay, this is defined as expectation of x square minus expected value of x whole square. Okay, you just have to use the formula and then you can find the variance also. Okay.
Ma'am, in this formula, putting the value of expected value, we can get the variance. No?
You have to put these two values, expectation of x square,
Yeah, ma'am.
expectation, yeah, and then you can get the value of variance of x. Okay. Okay, so we have to study discrete continuous joint distribution. Okay, so if you have seen this thing earlier, so here one variable is continuous and one variable is discrete. Okay, as you can see the name also, one variable will be discrete and one will be continuous. Okay, so let's see some basic things. If you have to find probability of A given B, if you have to find this conditional probability, what is the formula for it?
P A intersection B upon probability of B.
Yes, okay. So this is the formula. Now from this formula, we can write that probability of A intersection is equals to probability of B into probability of A given B. Right? Okay. So now, suppose we have two events. Okay. First of all, we have these two events. Suppose this is B1 and this is B2. Okay. Now we are defining one more event. Okay, this is A. So now you can see there is something which is common in A and B1. Okay, so this red part is common in A and B1, right? And this green part is common between A and B2. Okay, so now if you have to find the probability of A, okay, probability of A, if you have to find, what will be that? It will be equal to probability A intersection B1 plus probability of A intersection B2. Yes or no?
Yes, ma'am.
Yes,
Okay. It is the summation of these two things. Okay. Now from this formula, okay, which we have seen, okay, from here we can write that probability of A intersection B1 by using this formula. What we can write? It will be equal to what?
Probability
of B1 into probability of A given B1.
given B1.
Yes. Okay. And probability of A intersection B2, we can write probability of B2 into probability of A given B2. Okay. Is that clear up to this point?
Yes, ma'am.
Anyone has any doubt?
Yes.
Okay. So now we can see that it is the summation of these two components. So we can write it is summation of what? Probability of Bi. Okay. So A is some event, okay, which has some common in the events B1 and B2. So here I am writing as Bi, okay, and I is going from 1 to 2 and multiplied by probability A given Bi. Is that correct?
Yes, ma'am.
Okay. So here you can see that this A, B, so these are the events. In terms of probability, we have seen this thing. Okay. Now we have to study these things in terms of PDF. Okay. If you have a random variable, okay, for a random variable, we define PDF. So there we study marginal density function, joint density function, and conditional density function, right? So we have to study these things in that term. So you can consider that this is what? This is conditional probability. In terms of PDF, it will become conditional density, okay? And it is the probability of a single event B, B1 or B2, okay? So that is actually will be marginal probability, okay? So now let's see it in terms of random variables, okay? So now you have to see that if you have a random variable X, which is a discrete random variable, X is a discrete random variable. Okay, with some range Tx. Okay. So since it is a discrete random variable, so it will have PMF. Okay. So PMF, suppose Px. Okay, and here for each small x value, okay, which is belonging in this range Tx, we have a continuous random variable. Okay, suppose Yx, okay, or let's say Y. Okay, with PDF Fy. Okay. Okay, so now we have to see how can we find the PDF of Y. So this PDF of Y, okay, this will actually be the summation of Px, okay, and the conditional. And here we have to take the range of X. Okay, because X is varying, it is taking some values. Okay, so this is the marginal of X. Okay, and this is the conditional density. Okay, conditional density of Y given X. Okay, so in the question, you will be given the marginal of X. Okay, the distribution of X will be given, which is a discrete random variable, and you will be given the conditional of Y given X. Okay, and then you will be asked to find the PDF of Y. Okay, so by using the formula, you have to find this thing. Okay, and now you can just see how this formula is made. Okay, so you can see that this was the marginal, this was the conditional. Okay, so Y is based on the values of X. Y is conditioned on the values of X. Okay, so let's see a problem. So it will be clear to you then. Suppose X is some uniform distribution, okay, in -1 to 1. Okay, and you are given that Y given X is equals to -1. Okay, when X is taking value -1, then Y is following uniform distribution from -2 to 2, and Y given X is equals to 1. Then suppose it is following exponential with parameter 5. Okay, so you have to find marginal of 5. Okay, this is your question. Okay, this is something you have to find. Now just see how will you find this thing. So you have to use the formula and then tell what will be the values here in this formula if you have to put. Okay, first of all, what will be the value of this? What will be this PDF here? If it is following uniform -2 to 2.
1 by 1 by 1 by 4.
So it will be 1 by 4, right? Okay, and here it will be 5 e to the power -5.
Yes, sir.
Y. Okay. So now just put the values in the formula. We have to find the marginal of Y. Okay. So what two things we have to take? We have to take the marginal of X and this conditional, and we have to take it over the values of X. Okay. The summation is over x. Okay, because the values of x is varying. It is given in the question. Okay, so the first thing, when x is equals to -1, okay, then we have to multiply it with the conditional. So x is equals to -1. And then the other possibility is when x is equals to +1. And then you will multiply it with y given x is equals to 1. Right? Now just put the value. So what will be the probability x equals to -1?
1/2.
1 by 2. Okay. And what will be this value?
1/4.
1 by 4. Again, what is probability x equals to 1?
1/2.
1 by 2. Yes. And what will be this value?
5 and 2 e to
5
power
is -5 y.
Yeah, 5 into e to the power -5. Okay. So this is how you can find the marginal of y.
Excuse me, ma'am. Can you repeat the again? How you putting the value?
Okay. See, in the question, okay, the concept that we have seen, we have two things. We have two variables. One is discrete and one is continuous random variable. Okay. So for continuous random variable, the distribution will be given to you. Okay, distribution is given. So in this particular question, x is following uniform distribution with values -1, 1. Okay. The next thing is we have a continuous random variable. Okay, y, which is for each value of x. Or we can say that for each value of x, the conditional distribution of y is given. Okay, so when x is equals to 1, the conditional distribution of y is given, which is uniform -2 to 2. When x is equals to +1, then conditional of y is given, which is exponential 5. Now here we have to find the marginal of y. This is the question. Okay, so what we have to do here, in the according to the formula, we have to take marginal of x, okay, multiplied by conditional on that value. Okay, just look at this formula carefully. What is this? This is PMF of x. Okay, and this is conditional of y.
I know.
When capital X is taking value small x, and then you just have to vary. Okay, so first will be when x is equals to -1, and then this conditional y equals to, sorry, y given x equals to -1, and then when probability x is equals to 1 and y given x is equals to 1. Okay, and these values will be given to you in the question.
Yeah, ma'am. I know. I understand, ma'am.
Okay. Okay, now is that clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, now the next thing is continuous probability of discrete given continuous. Okay, if you have seen these topics earlier. So for studying this topic, you should know the Bayes theorem. Okay, this is the basic concept of this topic. Okay, so till now we have seen that probability of A. Okay, let's go back to the probability thing. Probability of A was equals to summation of probability of BI and multiplied by probability of A given BI. Okay. Okay, this is the concept of total probability. And we had this figure. This was B1. This is B2. This was A. Okay. Now, if you have to find probability of B1 given A. So according to the formula of conditional probability, we can write it is equal to probability of B1 intersection A divided by probability of A. Right? Now next we can write it as probability of B1 multiplied by probability of A given B1. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so this is the formula in terms of probability. Okay, so again, we just have to see it in terms of random variable. Okay, so suppose if you have x, which is a discrete random variable, and you have a y, which is a continuous random variable. Okay, and you have to find this conditional probability, x given y. Okay, you have to find this probability. Then how will you find it? Just compare it with the above formula and see. So this will be equal to, this is the marginal of x, okay? And then you have to multiply it with the conditional probability. Divide by, okay, so with what will you divide here?
PMF of y.
PMF of
It's not PDF of y.
PDF
Okay,
of
because y here is continuous and x is a discrete random variable. Okay, so this is the formula that we have to use. Okay, now again, let's take an example of it so it will be clear. Okay, suppose x following uniform distribution, okay, with -1 and +1. Okay, so again, suppose y given x is equals to -1. This is uniform. Okay, -2 to +2. And y given x is equals to 1. This is exponential 5. Okay, now here in this particular question, you have to find probability x is equals to -1 given y is equals to -1. Okay, this is something we have to calculate. Okay, up to this point, anyone has any doubt?
No, ma'am.
Okay, so by using the formula we can write, okay, so this will be equal to what? Just look at the formula and tell me what should we write here. So first term will be probability of x is equals to -1. Yes. And then what is the conditional distribution here? It is f y given x is equals to -1 and the y is -1. Okay. And then we have to divide it with what? Fy at point -1. Okay. So these values will be given in the question. Okay. According to that, you have to decide. So now our objective is to find these three values. Probability of x equals to -1 and this conditional and this marginal of y. Okay. So marginal of y we have calculated it in the previous question also. So fy of y, that this is something we calculated. Okay. So let's note it down from the previous question. It was 1/2 into 1/4 plus 1/2 into 5 e to the power -5y. Okay. So it was 1/2 into 1/4. And here we have to find the marginal of y at point -1. Okay. So at the place of y, we have to put -1. Okay. Okay, is that fine? Okay, so you can just calculate this value and then we have to find fy given x is equals to -1 at point -1. Okay, so tell me what will be this value? According to the question, what should be this conditional probability?
One by two.
It will be 1/4. Okay, it is 1/2 minus -2.
Oh yeah.
Okay, so which is equals to 1/4. Okay, so this is 1/4. Okay, and what is probability x is equals to -1?
1/2.
1/2. Okay, it will be 1/2. Okay, so now you just have to plug in all the values and then you can find. Okay, you can find this conditional probability. Okay, is that fine for everyone?
Yes, ma'am.
Fine.
Okay. Okay, yeah, so these were the topics for week 5. Now let's see the topics for week 6. Okay, so in week 6 we have joint density. Okay, so a function fxy, okay, it is said to be a joint density function f. Okay, so as we have seen the properties for a PDF, okay, for marginal PDF. Okay, so similarly we have some properties for joint PDF as well. Okay, so the first thing is that it should be greater than or equal to 0. Okay, and the summation, the integration, okay, integration of this function, okay, so that should be equal to 1. Okay, and he have to take these limits of x and y. Okay, so 1 will be the limit of x and 1 will be the limit of y. Okay, you can just interchange x and y. So first we have written x, so it will be x, and then we can write it y. Okay, these properties are clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, then you must have seen the 2D distributions. Okay, 2D uniform distribution. Okay, so suppose okay, so we are defining some region D in R square. Okay, so then we say that x comma y are jointly distributed and following uniform distribution, okay, in this D, okay, in this area, the region D. Okay, if they have the joint density okay, so this joint density is actually 1 upon area of D. Okay, where x comma y will belong in the D, and this will be 0 otherwise. Okay, so let's suppose this D is defined as a comma b into c comma d. Okay, so this kind of reason will be given to you. Okay, now what is the meaning of this thing? So it is actually defined as x comma y. Okay, so here x is lying between a to b, and variable y is lying between c to d. Okay, so we can take that, suppose x comma y are some variables, okay, which are following uniform d. Okay, which is which are defined in this reason d. Okay, this abcd can have any value that will be given to you in the question. Suppose, okay, let's take this is 1 comma 2 and 1 comma 3. Okay, so here we can see that x is between 1 to 2. Okay, and the y variable is between 1 to 3. Okay, now we can draw the reason. Okay, we can draw. So this is x axis, this is y axis, this is 0, 1, 2, and 3. Okay, so here you can see x is between 1 to 2 and y is between 1 to 3. Okay, so this will be the required area. Is that correct? Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, so this is the we are saying it as D. Okay, now tell me what will be the area of D here. So area of D,
2.
we have to take this distance. Okay, so this is 1, and this length, this is 3 minus 1, which is 2. So area is 2 here. Okay, so now here we can find the joint density of x and y. So what will be the joint density of x and y here?
1 by 2.
1 by 2.
It will be 1 by 2. Okay, and here x comma y is belonging in the D. Okay, it will be 0 otherwise. Okay, now in these kind of questions, marginal and conditional might be asked. So we first have to calculate the joint density. Okay, so joint you can find in this way. You have to find the area of this region D. Okay, and then 1 upon the area, that will be the joint distribution. And then margin, for marginal you can simply use the formula if you have to find the marginal. That is simply, okay, so marginal of x will simply be integration of joint over the range of y. Okay, if you have to find the marginal of y, okay, that will simply be fxy x comma y dx. Okay, so in this way you can find the marginal also. Okay, next is if next is the independence. Okay, so for independence also we have seen when two variables are independent, what is the condition for it?
You can multiply them.
X
Their
and
mark.
y. If and only if, yeah, if the joint, okay, if the joint probability, joint density, yeah, is equal to the product of marginals. Okay, so this is the condition that you have to check. Okay, and if you have to find a conditional, then also you just have to follow the same formulas that you have studied earlier as well. Okay, if you have to find the conditional, so conditional of y given x. Okay, so this is simply joint of x and y divided by the marginal of what? Marginal of x or y?
X.
X.
Marginal of x. Okay, simply yeah, similarly if you have to find f x given y, okay, then it will be joint of x and y divided by marginal of y. Okay, so these are the things in week 6. Okay, now we can solve some questions. Yeah, so this is the first question. Just try to solve on your own. So in the question, it is given that x is a continuous random variable with PDF. So PDF is given, okay, and find the PDF of y is equals to x cube. Okay, so in this question, you are defined a function of variable x. Okay, function of x is given, and you have to find the PDF of that function. Okay, just try to solve it on your own. So how will you solve this question?
We can use monotonic.
By using that
First, we will check if it is monotonic.
Yes, by
function.
using that monotonic function thing. Okay, that concept we have to use here. Okay, just try to solve option
B.
B. Okay. Anyone else? Okay, just give it a try. Then I will solve it.
Ma'am, is it B?
Have you all tried this question?
Yes, ma'am.
Yes.
Option B.
Option
Okay. Okay, so PDF is given. Okay, again, gx is what? So gx is equals to y. This is equal to x cube. Okay, what is the main formula? I will write the formula again. So Fy, this is equals to 1 upon g dash g inverse of y. Okay, and then here PDF of x in terms of y. Okay. Okay, so Okay, tell me what should come here. Okay, just try to understand the concept and tell me what value should come here.
The derivative of x cube is 3x square. For x square, we need to give the value
Yes.
of x in terms of y, right?
Yeah, so x, value of x will be y power 1 by 3.
Yeah.
Okay. Okay, we'll write all the terms. So g dash x, what will be the value of g dash x? It will be 3x square, right? And then g dash, so this will be g inverse y, okay? Because we know that gx is equals to y. So from here we can write x is equals to g inverse of y. Okay, so from here we have written this value. Now the value of x is y power 1 by 3. So y power 1 by 3 and whole square. So this is 3y power 2 by 3. Okay, next we have fx. So fx is equals to 4x cube. Okay, so fx in terms of y, okay, so that will be equal to 4 y power 1 by 3 and whole cube. Okay, so which will be equal to 4y. Okay, now just put the value in this formula.
Ma'am, y power 2 by 3
1 by y power minus 2 by 3.
Okay, so this value is 1 upon 3 y power 2 by 3. Okay, and here this is 4y. Okay, so ultimately it will be 4 by 3 and y power 1 minus 2 by 3, which will be 1 by 3. Okay, is that fine for everyone?
Yes, ma'am.
Okay, and you can see that x is defined between 0 to 1. Okay, x is between 0 to 1. If you make it x cube, that will also lie in 0 to 1. Yes or no?
Yes, ma'am.
Okay, so x cube is what? It is y. Okay, so that will also lie between 0 to 1. Okay, so from here you can see that option number 4 into, option number D, 4 into y power 1 by 3. So that will be correct.
Ma'am, option B.
Sorry, option number B, yeah. Sorry, my mistake. It is option number B.
4
Okay,
by
4 by 3 y.
Yeah.
4 by 3 y power 1 by 3. Yeah, sorry. Okay, so option number B will be correct. Okay, now is this question clear to everyone?
Can you slow down?
Yes,
Ma'am, you said that we have to differentiate.
Yes, yes. So we differentiated it. Okay. Gx was, what was gx? Gx was x cube. You have to differentiate x cube. That is 3x square. Okay, is that clear now?
Okay, ma'am.
Okay, and then at place of x, you put the value of x in terms of y. Okay, I hope it's clear to everyone. Okay, then try to solve the next question. Okay, so here you can see that we are given one discrete random variable, okay, and one continuous random variable y, okay, which is defined for the different values of x. Okay, so this conditional density is given to us. So we have to find the density, marginal density of y. Okay, this is the question. My voice is fine. this time, right?
Yes, ma'am.
Yes, ma'am.
Okay. One minute.
Ma'am, can you show the question again?
Yeah, just give me a minute. Yeah, this is the question. Okay, so in the question, x is equals to 0.4, Bernoulli 0.4.
Ma'am, please down the screen. Question is not visible.
Question is not visible?
Only the options are showing, not the question.
Ma'am, it's visible.
Yeah,
It is visible, ma'am.
Okay, my
Okay,
sorry,
so I
ma'am.
will solve this question. Yeah, so here x is following Bernoulli distribution. Okay, so Bernoulli, which means x will be taking two values, 0 and 1, right? And what are the probabilities for it? So it is following Bernoulli with parameter 0.4. Okay, so at 1, probability will be 0.4. Okay, at 0, what will be the probability?
0.6.
0.6. Okay, so this is given in the question. Okay, this thing is given in the question. Now, what next is given? That y given x is uniform x minus 1, x plus 1. Okay, so this thing is given. So now we have to interpret it. So y given x. Okay, so as you can see here in the question, x is taking two values, 0 and 1. Okay, so we have to find this thing, these two things. Y given x equals to 0 and y given x equals to 1. Okay, and this is also given in the question. We just have to put the values of x here. Okay, so if you put x equals to 0, that will be 0 minus 1 and 0 plus 1. So minus 1 to plus 1. Okay, so this is uniform minus 1 to plus 1. Okay, and if you put 1, so it will be 1 minus 1, which will be 0, and 1 plus 1, 2. Yeah, so it will be 0 to 2. So this is uniform 0 to 2. Okay, so if you have to find, if I write, what is the value of it? 1 upon 1 minus minus 1, okay, which is 1 upon 2. Okay, if I write this value, so it will be fy given x equals to 1. So yeah, so it is 1 upon 2 minus 0, which is also 1 by 2. Okay, so now our objective is to find the density of y, marginal density of y. Okay, so now according to the formula, okay, so here, okay, one more thing to notice. Here you can see that when x is equals to 0, it is between minus 1 to plus 1. And when x is equals to
Ma'am,
1,
how minus
it
1
is...
to plus 1? Is it minus 1 to 0? I think. Can you check again?
Okay, see, in the question it is given. Okay, so if you put capital X as a small x, then it is minus, it is between x minus 1 to x plus 1. You have two values, x equals to 0, x equals to 1. Just put 0 in this formula. So 0
Yes,
minus
ma'am.
1 is what? Okay, minus
Yes, ma'am.
1 plus 1. If you put 1, then it will be 0 and 2. Okay. Now here you can see that there is an overlap in these two regions. Okay. So 0 to 1. Okay. 0 to 1 is in this interval also and falling in this interval also. Okay. So if I make the diagram of it. Okay. Suppose okay, suppose on this axis we are representing the values of y. Okay, so values of y you can see it is starting from -1 and up to 2. So okay, so if I suppose this is -1.5, this is -1. Okay, and suppose here the values are okay, suppose this is the point which is 1/2. Okay, so from the figure, okay, from this information you can see that the conditional probability is 1/2. Okay, it is for all the points. Yes or no? When x is taking value 0, okay, then y given x is following uniform -1, 2, and the probability for the points is 1/2. Yes or no?
Yes, ma'am.
Probability for all the points will be 1/2 in this interval. Okay, and here also it is 1/2. So if I want to plot it, so here you can see that we can divide the interval. So it is actually -1 to 0, and then we have 0 to 1, and then we have 1 to 2, and this 0 to 1 is common in both the regions, in both these two things. Okay. Okay, so you can see that if x is 0, then this conditional is falling between -1 to +1. So -1 to -1 to +1. Okay, this is the uniform distribution. Okay, and when x is equals to 1, then this conditional is falling between 0 to 2. Okay, so this is this 0 line. Okay, this 0 to +2. Okay, so now from the figure you can see that this reason. Okay, this is common in both the things. Yes or no? Okay.
Yes, ma'am.
So now according to this we have to find the marginal for y. So you can see that here we have 3 intervals. This one -1 to 0, 0 to 1, and 1 to 2. So in these 3 intervals we have to find the marginals for y. Okay. So here we have 3 intervals. So the first one is when y is belonging in -1 to 0. Okay, so when y is -1 to 0, we have to use the formula. Okay, probability x is equals to x is taking value 0. Okay, and the conditional okay, this should be the formula. Yes or no? That we have already seen.
Yes, ma'am.
Okay, now just see when x is equals to 0, what is the probability? 0.6.
0.6.
Okay, so this probability is 0.6, and what is this value?
1/2.
This is 1/2. Okay, this is 1/2. Okay, now yeah, probability x equals to 1 is 0.4.
1/2.
Okay. Okay, yeah, this thing we have to be careful here. So you can see when x is equals to plus 1, okay? When x is equals to plus 1, y is taking values from 0 to 2, okay? When x is equals to plus 1, y is taking values 0 to 2. So for minus 1 to 0, here we are taking the values of y minus 1 to 0, okay? So in that case, this probability will be 0. Yes or no?
Please repeat
Yes,
that
ma'am, because
y
0 is included.
minus 1 0 part.
Because we have here, you can see from the figure, we have 3 intervals. Okay.
Yeah, okay.
From minus 1 to 0, then 0 to 1, and 1 to 2. From the main question, you can see when x was 0, it was lying between minus 1 to plus 1. And when x was 1, then this conditional of y, it was lying between 0 to 2. Okay. So in total, it is lying between minus 1 to 2. But here that 0 to 1, okay, 0 to 1, this is the common point, like common area for both the regions. Okay, that is here represented by this yellow color. Okay, so we have to divide it in the 3 intervals. Okay, so you can see that x is actually y is actually lying in these 3 intervals. Okay, so we have to find the probabilities for these 3 intervals. Okay, if you like know the PDF thing, we define the variable in the different ranges of values. Okay, in this way we define. Okay, so first of all, we have taken the intervals and then we will calculate the probabilities. Okay, this is what we are doing.
I'm here basically checking the support, right?
Yeah, it is support of y. Okay, so from minus 1 to 0, first of all, we are calculating the probability. Okay, so this thing will be 0. Okay, this conditional probability, if y is equals to minus 1 to 0, that will be 0. This probability will be 0. Is this thing clear to everyone?
Yes, ma'am.
Okay.
Can you explain one more time, ma'am? That
Okay, so all the other values we have written from the question. This value, f y given x equals to 1. Okay, so just see this part. When y is equals to, y given x equals to 1. Okay, when x is equals to 1, this condition, okay, it is taking values from from 0 to 2. Is this clear?
Yes, ma'am.
To this point?
Yes, ma'am.
So it is taking values from 0 to 2. Okay, but here we are considering the interval minus 1 to 0. Okay, here, so minus 1 to 0 is not in this range.
Okay, ma'am. Okay.
Okay, so that's why this probability will become 0.
0. Okay, ma'am.
Okay. Yeah, so it will be 0.3. If you solve it, it will be 0.3. Yes.
Besides from the formula, can we do it by the integration method as well, or we have to stick with the formula itself?
Sorry, what integration method?
Actually, I am asking for, like, you have taken the first interval of y, which is minus 1 to 0. So I am just asking, besides from the marginal method, can we use the integration method as well here and put the limit as minus 1 0?
See, here we have one discrete random variable. So we cannot directly integrate from minus 1 to 0. Okay, also we don't have any joint distribution that you can integrate.
We just calculated, right? It is 1 by 2.
Your voice is a little breaking for me.
Actually, we have calculated that now. It is 1 by 2. So putting that.
Your voice is not coming properly.
Ma'am, she's asking about why you don't. Ma'am, she's asking about why you don't take 1 by 2. You take 0. She's asking, like, I think that.
This point you are asking?
No.
Okay, your voice is breaking, so I'm not able to understand your question.
I'll figure it out.
Okay.
Ma'am,
Yes.
I'm sorry, I would ask you to repeat yourself in why the probability and the second summation turns to 0. I
Okay.
did not understand it properly.
Okay, see. Okay, see, first of all, we are given these two things. Okay. So x is taking values 0 to 1. Okay, it is defined as Bernoulli. Then for these two values, we have defined a conditional distribution of y given x. Okay, when x is 0 and when it is 1. Okay, now you can see that when x was 0, then it is taking values -1 to 1. Okay, and when x is 1, then y is taking values 0 to 2. Is that clear?
Yes, ma'am.
Okay, now let's see this thing. That first of all, we are calculating the probability for interval when y is taking values -1 to 0. Okay, and please don't be confused. Okay, so these values are for y. Okay, these are the values of y. Okay, and this 1/2 I wrote, it was the conditional density. It is the conditional density of y given x. Okay, so this 1/2 we already calculated by using the formula of uniform. Okay, that's how it is 1/2. And then I just make the diagram of it. Okay, and then we saw that there are 3 intervals forming. Okay, out of which this yellow color one is common to both 0 to 1. Okay, so we have to calculate the probabilities in these 3 intervals. So first of all, we are talking from -1 to 0. Okay, and when we're taking this probability, y equals to y given
Yeah,
x equals to 1, then y is taking values 0 to 2 only. Okay.
Understood, ma'am.
Okay, yeah, I will write one more thing for your understanding, that fy given x equals to 1. Okay, so as we define any PDF, it is 1/2. Okay, when this x is lying between, sorry, this y is 0 to 2, and it is 0 otherwise. So this 0 is coming from the otherwise case. Okay, because y is not from 0 to 2, it is between -1 to 0. Okay, now is that point clear to everyone?
Yes, ma'am. Ma'am, but if
Okay.
we'll be going for the next interval, then
Yes,
yeah,
yes.
understood then.
See the other
Yeah, thank you,
intervals,
ma'am.
yeah. Okay, then it will be different. So when, okay, now we will take when y is between 0 to 1. Okay. So when y is 0 to 1, okay, then again we will calculate the probability. Okay, so again we have these things, x equals to 0, x equals to this one. Okay, this is the basic formula. Okay, okay. So now probability x equals to 0, the marginal of x, it was
0.4.
at, it is 0.6. Okay, at 0. Okay, this is 0.6. Okay, and at 1 it was 0.4. Now we have to put these two values, these conditional. Okay, so when x is equals to 0, what is the conditional value for y?
1/2.
Okay, so it is 1/2. Okay, and you can see that we are taking the interval 0 to 1. Okay, so 0 to 1 is lying in both these two cases. Okay, 0 to 1 is common in both the cases. Okay, so they will have their values, which is 1/2. Okay, you can see it is this 1/2 is from 0 to 2. So when it is 0 to 1, then also the value will be 1/2. Okay, when x is equals to 1, this conditional will be 1/2. Okay, so this will be 1 by 2. And for x equals to 0 also, okay, this is 1 by 2. Okay, because 0 to 1 case is included in that. Is that clear to everyone?
Yes, ma'am.
Okay. Just calculate it.
0.5.
Yeah, it will be 0.5. Okay, now the next interval is 1 to 2. Okay, so we will calculate probability for
Here x0 is equal to 0.
Okay, so this is the basic formula we are using. Okay, so probability x equals to 0 is 0.6 again. Probability x equals to 1 is 0.4 again. Okay, now when x is equals to 0, okay, when x is equals to 0, then this y taking values -1 to 1 only. Okay, so this probability, this conditional probability will become 0. Okay, because here we are talking about the interval 1 to 2 when y is 1 to 2. Okay, so this conditional probability is actually 0 here. Okay, and this one when x is equals to 1. Okay, so when x was equals to 1, then y was taking values 0 to 2. Okay, so 0 to 2, which means 1 to 2 is already included, so that will have the value 1 by 2.
0.
Okay, 1 by 2. 1 by 2 from where? This is this 1 by 2 we have put. Okay, now is this clear to everyone?
Yes, ma'am.
Okay, so this is 0, this is 0.2. Okay, so this will be 0.2. Okay, so now you can just match which option is matching with our answer. Okay, so you can see that first of all we divided these three intervals -1 to 0, 0 to 1, and 1 to 2. So these intervals are given in these two options. Now just match our probabilities. So it is 0.3, 0.5, and then 0.2. Okay, so 0.3, 0.5, 0.2. So option number B is correct. Okay. Is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Excuse me, ma'am.
Hmm.
Ma'am, can you please zoom out the screen icon so that I can take screenshot?
Ma'am, can I get this PDF?
Yes, yes, it will be uploaded.
Okay, ma'am. With all this writing part also, no? Notation?
You will get this. Yes, you will get this.
Okay.
Now with the solution itself. Okay, then move on to the next question. Okay. So suppose x and y are two independent random variables with probability density function as these. Okay. So PDF of x and y are given. Calculate the value of expectation of xy. Okay. So what will be the value of expectation of xy here? How will you calculate it?
Expectation of x into expectation of y.
Yeah, because x and y are independent. Okay. So we can write it as the product of their individual expectations. Okay. Since x and y are independent. Okay. So we need to calculate the expected value of x. Okay. Simply it will be
C option.
So it is 8 upon x cube dx. And what will be the limits here?
3 to infinity.
2 to infinity.
2 to infinity. Okay. So it is x into the PDF.
Ma'am, 2 would be included.
Yes, because it is PDF. Okay, so PDF, which means variables are continuous. Okay, so in continuous, at the point the probability is 0, so you can include that. Okay, it is not a discrete. If you take from 3, then the points from 2 to 3, between 2 to 3 will be missed out here. Okay.
Thank you, ma'am.
Yeah, so you just have to integrate it. Just tell me the answer.
4.
So 1 upon infinity is 0. Okay. So this will be equal to 4. Similarly, calculate the expected value of y. So this is 2y and 0 to y. So y into 2y dy. Okay. So 2 and then it will be y cubed by 3. 0 to 1. So it will be 2 by 3. Okay. So from here, expected value of x into expected value of y is 4 into 2 by 3, which is 8 by 3. Okay. So option number C is correct. Is it clear to everyone?
Yes, ma'am.
Yes.
Okay, this is.
How many questions left?
Sorry, what?
How many questions left?
In total, we have 9 questions, but we can skip few of them. Okay. See, this question is very easy. You can try it on your own. Okay, so this question is x and y be two continuous random variables with the joint PDF. Okay, so we have to find the value of c. So how will you find it? What we have to do here?
Integrate and equate to 1.
We just integrate it for both
Yeah, so we have to
DIY.
integrate the joint. Okay. And that should be equal to 1. So x is from 0 to 1. Y is also from 0 to 1. And this is x plus cy square. Okay. And dy dx. If you can solve it on your own, then I will skip it. And we can move on to the next question.
Yes, ma'am, we can.
Okay, everyone can do this question? Okay, the next question. The joint density of continuous random variable x and y is this. So first of all, you have to calculate the value of k. So again, you have to do the same thing. Okay, so x is between 0 to 1, y lying between 0 to 1. PDF is x plus y divided by k. Okay, dy dx, that should be equal to 1. So from here, you can find the value of k. Okay, do you want me to solve it?
No, ma'am.
No.
No, ma'am.
Okay. So from here, the value of k will be equal to 1. Now the next question is.
Ma'am, can you give some hint? Ma'am, can you give some hint how do we solve that question?
This one?
Yes, ma'am.
Okay, I will just quickly solve it. Okay. See, you have to integrate it. You have to integrate the first integration, this thing. And then you will integrate with the second. Okay. So first of all, we are integrating with respect to y. Okay, and here we are taking the limits of y. Okay. So k is a constant that we can write out of it, out of the integration. Okay. So now we have y from 0 to 1, x plus y dy. Okay, this part. And the entire dx equals to 1. So 1 upon k, x equals to 0 to 1. So this will be x and y, okay, because we are integrating with respect to y. Next term will be y square by 2, okay, and the limits will be from 0 to 1. Okay, dx 1. Now you just put the limits. So this will be x plus 1 by 2.
1 by 2.
Okay, and then it will be dx equals to 1. Now you have to integrate it with respect to x. So that will be x square by 2 plus 1 by 2x. Limits are 0 to 1. And this is 1 upon k equals to 1. Okay, so you can just put the limits.
K
1 by 2 plus 1 by 2 equal to 1. Yeah, so from here, the value of k will be equal to 1. Okay. Okay, now solve this question. What is the value of x is less than 1 by 2 and y is less than 1 by 2? You have to find. Okay. So you can see the original, the main question. So here you can see the range of x is from 0 to 1. Okay. And y is defined between 0 to 1. In the question, you are asked to find x is less than 1 by 2 and y is also less than 1 by 2.
0 to 1.
Yeah, so what we have to find that x will be 0 to 1 by 2 and y will also be 0 to 1 by 2. Okay. This 0. Okay, so these are the lower limits for x and y. Okay, you have to identify it from the question. So what you have to do actually, so x will be from 0 to 1 by 2. Y is also from 0 to 1 by 2. And then you have to integrate the joint probability, joint density, which is 1 upon, which is x plus y. And the value of k was 1. Okay, so divided by 1, which is the same thing. Dy and dx. So now can you do it on your own?
Yes, ma'am.
Ma'am, can you show the question once again? First question. Okay, ma'am.
Okay, I hope everyone can do this now. Okay, so this is the next question. So here the joint density of two continuous random variable x and y is given. And you're asked, are x and y independent? Okay. So how will you check x and y are independent or not?
We individually find the fx of x and ff of y and then product it. If it is equal to fx by x comma y, then it is independent.
Find joint probability and we can calculate by the.
Yes, so we have to find the marginals here and then we will find the product of marginal. So what will be the marginal of x? So y is going from 0 to infinity. Joint is e to the power minus x plus y dy. Okay, so this is something we have to find. So e to the power minus x we can write out of the integration. Okay, that will be considered as a constant. Okay, so this will be e to the power minus x. This will be minus e to the power minus y from 0 to infinity. 0 and minus minus plus e to the power 0. Okay. So that will, this is x, not infinity, sorry. So this will be e to the power minus x. Okay. Is it correct for everyone? Are you getting the same value?
Yes, ma'am.
Okay, similarly, you can find the value of fy. Okay, marginal of y. So that will, if you integrate, that will be e to the power minus 5. Okay, so now you can check the product of marginals. Okay, which is e to the power minus x, e to the power minus y, which you can write like this. Okay, and this is equals to joint density. Okay, so we can say that yes, x and y are independent. Okay, is that correct? Oh, I mean, is it okay for everyone? Anyone has any doubt?
No, ma'am.
No, ma'am.
Okay. Yeah, then this is the question. Find the value of probability x is less than 5. Okay, so the joint probability, joint density, sorry. Okay, joint density is given to you. Okay, you have to find probability of x is less than 5. So in this question, you need to make the diagram of it. Okay, so you can see x less than y. So first of all, if you take the equality, that is x is equals to y. So if you know x equals to y line is this at 45-degree angle. Okay, now tell me what will be the area for x is less than y. What area it will cover?
Then can you again show the question ranges?
Okay, this is the question. Okay, I will write the.
Under the line, ma'am?
Upper part of the line.
Okay, so this is the question. Okay. Okay, so x is less than y. So how will you decide it whether the reason is this one or this one? Okay,
The
there is a way
maximum
to check.
value for x should be y.
Okay, so there is a way to check this thing. So let's take a point in this reason. Okay, let's take this point. This is some point. Suppose this is 2, 0. Okay, so this point is falling below the line. Okay, so I'm taking a point from this reason. Okay, now see, this 2 is the value of x and this 0 is the value of y. Okay, so here you can see that x is greater than y. Is that correct? Yes or no? Okay,
Yes.
so this reason below the line will be x greater than y. Okay, similarly, you can check further here. Okay, this point is suppose it is 0,5. Okay, it is falling on the y axis, so the value of x will be 0, and this is suppose some value of y, suppose it is 5. So here you can see that x is less than y. Okay, so which means that above this line is the reason for x greater than x less than y. Okay, so this is how you can just take a random point, okay, in any of the reason, and you can decide, okay, which will be the correct inequality for that reason. Okay, so now I can see that, okay, this one is the required reason for us. Okay, now in the question you have to see the limits for x and y. Okay, this line we know. Else we have that x is falling between 0 to infinity, y is falling between 0 to infinity. So this is the 0 point. So by, okay, yeah, so x is starting from this point and going up to infinity. Okay, up to infinity. Y is starting from here and going up to infinity. There is no end. Okay, so actually this is a like open region. There is no boundary point. It is not a closed region. Okay, so now you have to decide the limits for x and y. So we can take a strip which is like this. So now you can see that if I take that this x, okay, suppose this x is starting from the 0 and going up to this line, okay. Here also it will be going up to this line. If you go forward, that will end up to this line only, right? So the upper limit for x will be y. Why it is equal to y? Because of this inequality, okay, because of the line, okay. So now x is going between 0 to y. What will be the limits for y?
Zero to infinity.
Yeah, it will be 0 to infinity, okay. So x is going like this and y is going like this. It is going up to infinite point, okay. So this is the limits we have decided. Now you just have to integrate the joint density, which is e to the power minus x plus y, okay. Dx dy.
Can we take here in other way, ma'am? If we are taking dy first, so y is from 0 to x and x is from...
Yeah, that is also possible. That also is possible, okay. So you can take the dependent limits of y, okay. So suppose y is going from so then we can take the strip in this method, like, okay. So the lower limit for y will be 0. Sorry, lower limit for y will be x, okay.
Yeah.
So it will start from x and will go up to infinity, okay. Lower limit is x and will go up to infinity, okay. And for y, for x, it will be 0 to infinity.
Okay. So it will be x to infinity, not like 0 to y. Okay.
Okay, and again you have to integrate the joint density. Okay, so here we are integrating with respect to y first, and then we are integrating with respect to x. Okay, so you can take in both the ways. Okay, do you want me to solve this, or you can do it on your own?
Now we can do.
Okay. Okay, so I will solve the first one. Okay. So we have y going from 0 to infinity. Okay, x going from 0 to y, and e to the power minus x plus y dx and dy. Okay, just a minute. Okay, so first we are integrating with respect to x. Okay, so we can take y out of it. Okay, so x going from 0 to y e to the power.
Excuse me, ma'am.
Yes.
How many questions are you doing in this class? Because I have a class of Python.
Only I think 2-3 questions more are there. Or if you want to leave, you can just leave and you can see the recording.
Okay, ma'am.
Okay. Okay, so you have to integrate it. It will be minus e to the power minus y. Okay, 0 to. It is e to the power, minus x. Okay. and the limits are 0 to y and then dy. Okay, now you just put the limits here. So it will be minus e to the power minus 5, then minus plus e to the power 0. Okay. So this is 1 minus e to the power minus y dy. Okay, you can just multiply. You can integrate it. Okay, so this will be minus e to the power minus y. This will be minus e to the power minus 2y divided by minus 2. And then you can just put the limits. First part will become 0 if you put minus infinity. Okay, then it will be minus.
Both will be 2.
Yeah, if you put infinity, then these two will be 0. Then you have to put 0. Okay. This will be 1 by 2. Okay, so ultimately it will be 1 by 2. Okay.
Okay, ma'am.
Okay, is this question clear to everyone? Okay,
Yes,
the
ma'am.
only thing is that you should be able to understand the limits. Okay, rest is that you should know how to do this double integration. Okay, so the main task is to identify the limits. Okay, and the next thing is you should be able to do these integration things. Okay, so you should know.
We are taking in with respect to x, we have to make a parallel line to it according to the x-axis, and whatever y value comes, that we have to give the limit, right?
Yes. Okay, the thing is, in the question you will be given some inequality and the range of x and y. According to that, you have to draw the reason. Okay, and you have to see according to the inequality which reason is coming. You have to draw the line first. Okay, and then you have to decide the reason, and then you have to find the limits.
Yeah, for finding the limits, we can draw a parallel line to the x-axis, and accordingly what value y gets, that we can give the limit for x, right?
Yes, you can make this strip. Yeah.
Okay.
Okay, this you can make parallel to x-axis, or you can make a parallel to y-axis also. Okay, depends on the different question or different figures. Which one is more convenient or which one is more easy. Okay, that you can do in both the ways.
Okay.
Okay, this is the next question. So x comma y is following uniform D. Okay, and this is the reason area. Okay, so 1 comma 2 and 1 comma 3. So find the joint density.
B.
So if you
Option
draw
B.
it, yeah, if you have to draw, this is 0, 1, 2. Okay, so x is 1 to 2 and y is between 1 to 3. This is the same question we already seen. So it is 1 by 2. Okay, area will be 1 by 2. Option number B will be correct. Okay. The next is the joint probability density of two continuous random variable x and y is given as this. So find the marginal density of x. Okay, so here you can see that we are given the limits of x and y which are dependent on each other. Okay, so you have to find the marginal of x. So for finding out the marginal of x, you have to integrate the joint. Okay, integrate the joint with respect to y. Okay, so here you can see that joint is 8xy. So what will be the limits of y here for integrating this function?
0 to y.
Limits of y, not x.
0 to x.
Yeah, it will be 0 to x. Okay. So it is actually between 0 to x. So we have to take the dependent limit. So you can see that y, the lower limit is 0. Okay. And the upper limit is x. Or you want to draw the reason, if you want to see. Okay. You can draw it. So here you can see that what lines we have. We have y equals to 0, x equals to 1, and this y equals to x line. Okay. From the inequalities, you have to identify. So y equals to 0 is this x-axis. Okay. X-axis is y equals to 0. Then we have x is less than or equal to 1. So this line is x is equals to 1. Okay. And then we have x equals to y line. So x equals to y line will be like this. Now you have to identify the reason. Okay. So just look at this thing carefully. X is less than or equal to 1. So which means this line, okay, to the left hand side, the reason is. Then we have x is greater than y. So in the previous question, we have seen that x is greater than y is the below this line. Okay, which means this one. Okay, and then we have y greater than 0. Okay, so y greater than 0, which means it is indicating to upward direction. Okay, so now we can see that this triangle is the required reason for us. Is it clear to everyone? Okay, this triangle is the reason. So now here you can see if you have to take the limits of y. So y is starting from here and going up to this line. Okay. So this line is what? Y equals to x line. So y is starting from 0. Okay, this is 0 going up to x only. Okay, is that clear to everyone?
Yes, ma'am.
Okay. Okay, so next you have to find the expected value of x. So this you can do on your own. Expectation of x. Okay. X into the. Okay, you can integrate it, or do you want me to integrate?
We can do it.
Okay, so whatever comes here, you just have to take x into fx dx. Okay, and just take the limits of x. Okay, so here when you will be taking the limits, it will be 0 to 1. Okay, here you have to take the independent limits because here we are calculating the expectation. So here you can see from the question, it is lying from 0 to 1. Okay, and then this is the last question. So here we have x comma y is defined in this reason. Okay, x plus y is less than 3, x is greater than y, sorry, x is greater than 0, y is greater than 0. So first of all, we will make the diagram. Okay, so this is y equals to 0 line, this is x equals to 0 line, and then we have x plus y equals to 3 line. So x plus y equals to 3 line will look like this. Okay, now the inequality is that x plus y is less than 3. So less than 3 will be this reason. Okay, then we have x greater than 0, y greater than 0, which means they are indicating these directions. Okay, so again we have this triangle. Okay, this triangle is the required reason for this question. Okay, so now what we have to find in the question, we have to find what is the marginal density of x. Okay, so first of all, we will have to find the joint of x and y. Yes or no?
Yes, ma'am.
Okay, so for calculating the joint fxy, x comma y, we should know the reason of this, the area of this triangle. Okay, so this point is 0, origin. Okay, this point will be 3 comma 0. Okay, this point will be 0 comma 3. I hope everyone knows these things, how to find these points.
2 by 9, ma'am.
Yeah, so it will be 1 upon area of D. So the area of D will be 1 by 2, okay, into 3 into 3. Okay, so it will be 2 by 9. Is that clear to everyone?
Yes, ma'am.
Okay, so this will be 2 by 9. Now you just have to find marginal of x, which will be integration of the joint over the limits of y. Okay, so what will be the limits of y here? Okay, so again you have to take the dependent limits. Okay, so which means you can draw a strip. So y will start from this point, okay, and it is going up to this line, right? Okay, it is starting from this point. This at this line, the value of y will be 0.
Yes.
Okay, so y is starting from 0 and going up to this line only. So from here, okay, from here you can find the value of y. It will be 3 minus 6. Okay, so the upper limit of y will be 3 minus 6. Okay, now you just have to integrate it. So this is y going from 0 to 3 minus 6. Joint is 2 by 9 dy. So simply it will be 2 by 9 3 minus x. Okay, so this will be the marginal of x. Okay, okay, so you can see 2 by 9 3 minus x. Okay, and here you can see that x is lying between 0 to 3. For x you have to put the independent limits. When you take the range, okay, you can see that x is lying between 0 to 3. Okay, so the range of x will be 0 to 3 here. Okay, is that clear to everyone? Okay, one more question we have. So again, it is not very tough. First of all, you have to find the value of c. Okay, you can do it on your own.
Yeah, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
And then we have what is the probability that the pressure change during the chemical process? Okay, so for this you need to read the main question first. The main question is that a random variable x represents the temperature change and y represents the pressure change during a chemical process. And then the joint is given. Okay, so the question is, what is the probability that the pressure change during the chemical process more than 0.5, given that the temperature change is equal to 0.5? Okay, so the pressure change was represented by y. You can see y is representing pressure change. Okay, so in the question it is asked to find the probability that y greater than 0.5, given that temperature change is equal to x is equal to 0.5. Okay, so according to the formula it will be that y greater than 0.5, okay, x equals to 0.5, which means the joint probability, and then you have to divide by this. Okay, see, okay, so this will actually be the marginal of x, okay, because x is a continuous random variable. Okay, and in the numerator it will be the joint of x and y. Okay, so x is the value of x is fixed here 0.5 and y is greater than 0.5. Okay, so these two things we have to find, and in the question we are given the joint distribution. Okay, so we need to calculate marginal of x. Okay, so marginal of x will be, so you can see that y is lying between 0 to 2 and the value of c is 0.25, which is 1/4. Okay, so y going from 0 to 2. Okay, and the joint was cxy, so c is 1/4 xy dy. So it will be y square by 2. Okay, 0 to 2. Okay, now we have to find the marginal of x at point 0.5. So it will be 0.5 divided by 2. Okay. So again it will be 0.25, which is 1/4. Okay. Next we have to find this joint, and here x value is fixed to be 0.5. Okay. So fxy 0.5, y greater than 0.5. So this is actually what? Okay, so in the joint distribution, you can put the value of x as 0.5. Okay, so x is 0.5, c was 1/4, and y. And then you have to integrate with that y is greater than 0.5. Okay, so y starting from 0.5, and what will be the upper limit? What will be the upper limit for y?
Less than 2 y.
Yeah, it will be 2. Okay, upper limit will be 2. You have to integrate it with respect to y. Okay, you can just solve it. So that will be y square by 2. Just solve it and tell me what will be the value. So when you solve it, it will be equal to 0.234 something. Okay, and then the final value, y greater than 0.5, given that x is equals to 0.5, that will be equal to 0.234 divided by 0.25. Okay, it was 0.25, and then the final value will be something 0.94 something. Okay, you can just check the answer. It will be in this range. Okay, is that clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Again, we have few questions. Thank you.
Option 4, 1/4.
It is also a similar kind of question. So you can see we are given this reason. So it is 0, 2, and this is 2. So this is the reason. Okay, this is x, this is y. So area will be 2 into 2, which is 4. Okay, area of D will be equal to 2 into 2. Okay, so the joint density will be 1 upon 4. Okay, which is option number D. Okay, is it clear?
Yes.
Okay.
Yes, ma'am.
The next. Okay. The next we have x plus y less than 2. Okay. So again we need to draw the reason. You can see x plus y less than 2 will be something like this. Okay, this line is x plus y is equals to 2 line. Okay, and the support of x and y is 0 to 2. Okay, x is between 0 to 2 and y is also 0 to 2. So this point is actually what? 2 comma 0. Okay, this is 0 comma 0 and this is 0 comma 2. Okay, so again we can see that if you want to draw the line, so this will be x equals to 2 line, sorry, y equals to 2 line. Okay, and then you can draw this line. Okay, and you can see. Okay, so this will be the reason. Okay, x plus y is less than 2. Okay, okay, so this triangle is the reason for us. Okay, this is the required reason. Okay, now you can just integrate. So again you can take, okay, so y, if you want to draw like this, so y will be going from the 0. Okay, y will start from 0 and will go up to 2 minus x. Okay, and the range for x will be 0 to 2. Okay, and the joint distribution is 1 upon 4. Joint density is 1 upon 4. So 1 upon 4 and then dy and dx. Okay, now you can integrate it. So that will be y by 4 going up to 0 to 2 minus x. It is x 0 to 2 dx. Okay, and then it will be 2 minus x divided by 4. Okay, you have to integrate it from 0 to 2 dx 1 by 2x minus x square divided by 8 and then 0 to 2. Okay, so that will be 1 minus 1 1 by 2, which is 0.5. Okay. Yeah, so this was the last question. I hope it's clear to everyone.
Ma'am,
Yes.
whenever probability is asked, we have to integrate, and whenever the joint distribution is asked, we have to just do the normal mathematics, right?
So whenever you are given this reason kind of question, okay, this area if it's given, then to find the joint, you have to find the area of the reason, area of D. Okay, that will give you the joint distribution, joint density. Okay, and if you are asked to find these probabilities, then you again will have to draw the reason. Okay, you have to draw the support of x and y. Okay, that will be given in the question. From here you have to identify and you have to draw this line. Okay, whatever is given in the question.
And in the end, when the answer is about to come, do we have to divide by the joint distribution or by the area of the region?
No, we are not dividing it with that. Anything?
Actually, joint we are taking as 1 by area of that, right?
Yeah, the joint distribution is 1 upon the area. Okay, you have to find the area of this D and then 1 upon area of D. Okay, 1 upon area of D, that is the joint density. Okay. Now is that clear? Okay, anyone else having any doubt?
No, ma'am. Thank you for this session.
Okay, thank you everyone.
Thank you so much, ma'am. It was very clear.
Okay, thank you everyone. All the best for your exams.